Alright, so in this lesson we're going to be solving some quadratic equations, and specifically, you can see there's just one objective here. We're going to solve quadratic equations by factoring. Okay, it's the most basic way to solve quadratic equations. In this whole unit we're going to learn tons of ways, and this will be the first one. Okay, so here is a warm-up question. If the product of A and B equals 0, so we've got two numbers, A times B, it equals 0, what's got to be true about A or B? I multiply two things together to get 0. What's that mean? It means that you had to start off with 0, right? So maybe A is 0, or maybe B is 0. It's possible that both of them are 0, okay? And this is called something in math called the zero product property. So if the product of two expressions is 0, then at least one of those original expressions had to be 0 to start with. Okay, and this forms the foundation of how we're going to solve quadratic equations. So if we can get it equal to 0 and then factor the left-hand side so that you have a product of two things, then at least one of those products or one of those factors has to be equal to 0. Okay, so that's the basic foundation for this whole entire lesson. Okay, so our objective here is to be able to solve quadratic equations by factoring. And in this image here, you've got a fountain. I think it's in like an airport or something. And in this fountain, you can see the water, when it shoots up, it forms the basic shape of a parabola, right? And this is true of like even a water fountain. Whenever you shoot the water out, it makes a parabola, and parabolas are the shape of the graph of a quadratic function. Okay, so what I want you to do, if you have your graphing calculator handy, or your emulator, I want you to go to your graphing calculator, go to y equals, and type in this equation, y equals x squared minus x minus 6. So I'll give you a second, maybe pause that, type that thing in the calculator, and let's graph it. Okay, and the question here is, well, where does that parabola, that's that U shape there, where does it cross the x-axis? So here, let me put the graph up here. There we go. And it touches the x-axis at two places. One of them is at 3, 0, and the other one is at -2, 0. Okay, and those, of course, are called the x-intercepts. Whenever we had a line, the most that we could ever have was one x-intercept. Here with a parabola, it's possible that we could have two x-intercepts, two places where the parabola crosses the x-axis. Alright, so again, the shape of a quadratic, the shape of the graph of a quadratic function is called a parabola, and the x-intercepts are where the parabola intersects the x-axis. Okay? Alright, now I want you to think about something. Whenever, if you have your x-intercepts touching the x-axis, what's the y-coordinate of any point on that x-axis, right? The same thing is, what is the y-coordinate of those x-intercepts? It's 0, right? Okay, so let me ask this question. How many y-intercepts can the graph of the quadratic function y equals ax squared plus bx plus c have? How many y-intercepts can it have? Think about it for just a second. Well, if it is a function, it can only touch the y-axis, which is a vertical line, one time, right? So, so that it passes the vertical line test. So since it's a function, it can only have one y-intercept. How many x-intercepts can the graph of a quadratic function y equals ax squared plus bx plus c have? Well, we just saw one where it had 2. Can it have more than 2? Can it have less than 2? Think about this. Where can that parabola be in the coordinate plane? So it's possible that you can have 2 of them, 1 of them, or no x-intercepts at all. Let's look at this on Geometry Sketchpad for a second. Alright, so as you can see, I've got myself a parabola graphed. We're going to learn that this thing is graphed. The equation is what's called in vertex form. And I can change a couple of things here. I can make this the parabola fatter or skinnier by moving this slider. Look at the two roots there. The two roots mean where it touches the x-axis there. And obviously I have 2 of them. Crosses the x-axis twice. but it's possible that, let's just move this vertex up a little bit. I still have 2, I still have 2, I still have 2. And now, oh, look at that. I've got, depending on where I move it here, there we go. I have just one of them now. And that happens when the vertex is exactly on the x-axis. And then finally, it's possible that I have none of them, right? So we're talking about x-intercepts here for a parabola. It's possible I have none. It's possible that I have 1 if the vertex is on the x-axis. And in most cases, I'm going to have 2 where it would cross the x-axis in 2 different places. Okay, so if you wanted to find the y-intercept of a quadratic function, what would you do? So if it is the y-intercept, this means that the x-coordinate is what? X-coordinate is 0. So you just plug 0 in for x and you solve it for y. Isn't that an interesting picture? Internet is full of interesting pictures like that. There you go. Nice color scheme here with the purple boots and the purple thingamajiggy over there. Nice. Okay, so we're going to do that right here on this exercise. Find the y-intercept of y equals x squared minus 6x minus 7. So what are we supposed to do if I want the y-intercept? That means x is equal to 0. So I'm going to go y equals 0 squared minus 6 times 0 minus 7. And if you're paying attention, of course, you would understand that this is the same thing as the constant term there, y equals negative 7. The y-intercept is 0, negative 7. So think about this for a second. If you had y equals mx plus b, what's the y-intercept? It's the constant term. If you have y equals ax squared plus bx plus c, what's the y-intercept? It's the constant term. The reason why is because x is being 0, so that's gone, so you have just b. And the other one, x is gone because there's 0, and you're left with just c. Alright, so that concludes this video, and the next one we're going to actually talk about finding those x-intercepts.